Swayam Prabha. Digital India. Educated India.
Okay. So how do we compute this probability? So if you look at the computation of the probability of the whole sequence, it is nothing but a joint probability, right. So probability of the first word with the entire one, probability of the second word with the rest of the words, and so on and so forth. If you look at it, it's a very long sequence of probability, and you have to multiply each and every one of those to find the probability of the given sentence. Okay, what the chain rule does is it decomposes the joint probability into a product of conditional probability. Okay. Actually, what I would do is I will go through the theory part of that, and then at the end of this I will take an example and then see why is it very hard to compute the joint probability, and then why are we really using a chain rule first to create the product of conditional probability for the same sequence, and then later how it could be approximated so that the computation complexity can be reduced and so on. Okay. So, right now let us stick on to the theory part of that, and then let us define those equations, and then later we will use those equations to see how those things can be reduced in terms of complexity, and then how we can compute the probability of each sentence and so on. Okay. It is possible, if you look at the chain rule, we can compute the probability using the conditional probabilities. So, that is what I have done in this case here, right. Okay. So, I have taken the first word, and then the next one is computed based on the word W1, and then if you look at the probability of finding this is conditioned by these two words, and then and so on. So, it is a product of the conditional probabilities, which can be written in a very simple form, concise form in the mathematical notation. Okay. So, we can compute, I am just writing it as a history. History is nothing but these two words, right, in a simplified form. It is not really reducing our computational complexity, right. So, we have to use a different mechanism in order to reduce our complexity. Also, we use lot of innovative ways, as I mentioned earlier, to form new sentences. So, it is highly unlikely that a new sentence that we are forming differently would be available as part of that. Only parts of those sentences would be available as part of the corpus. So, how do you deal with that situation when new sentences are formed and we are not able to really find the conditional probability for such a long sentence in the existing corpus. So, we need to split that into smaller chunks of words rather than long chunk that we have seen earlier in the chain rule decomposition. We can use the Markov assumption. Here what it does is we can approximately change the equation into a different form, where we define that the future behavior of the dynamic system depends only on the recent history, not on the entire history. We require only the recent set of words to compute the probability. So, we are saying that it is possible to approximately rewrite the statement that we had, or the equation that we had seen earlier, into an approximate form, where we would only use the recent history and not the entire history. Okay. So, we are rewriting this in terms of n grams, which are smaller in number, could be 2 bigram, could be trigram, or 5 grams. We are not using n grams of size greater than 10 or 15 and so on and so forth, or considering the entire sentence. So, when we do that, it is going to be only an approximate, not going to be an exact one like what we consider, or when we consider the entire sentence. So, there could be some error in the computation, which could be minimal, smaller, and so on. So, there is always a possibility that the sentence that we are forming using the Markov assumption need not be right every time. Okay. So, that is the caveat that I want to place at this point in time, but it is a good approximation for most of the cases. Since we are considering only the nearest neighbors in terms of 3 words or 4 words as the history, it is possible that this assumption may work 95% of the time. Okay. The 5% of the time we still have to deal with. Maybe when the computing power increases beyond what we have, it may be possible for us to deal with that higher number in the later cases. Okay. So, in this case what we do is we rewrite the entire sequence as follows. So, if you look at this, the k is your n gram, could be 2, 3, 4 and so on. So, if you look at the history, it is going to be only between we are going to be considering the history for this word k using a bigram, trigram, or 4 gram, or 5 gram. Okay. So, this is the assumption that we are making, and we are trying to reduce the complexity in terms of computation using this approach. Okay. Hello everyone, continuing the discussion on the probability and the application of probability in the natural language processing. We are going to be talking about the language model using probability. Okay. We had already seen this slide earlier. Again, for the sake of clarification, I am going to be repeating this slide. So, the language model that we are talking about using the probability contains 2 things. One is finding the next word or predicting the next word given the first 2 words or 3 words or 4 words, or if you are given a sentence, trying to find out what is the probability of that sentence occurring in a given corpus, or what is the probability of that sentence, or what is the legality of that sentence in that particular corpus. Okay. Or supposing if there is a new word that is available as part of this sentence, the probability of the sentence would become 0 if you absolutely take the product of each of the probability of the words that are found using the corpus. So, let us going to be looking at those examples where we are going to be first finding out what is the next word, and then we are going to be giving you an assignment in terms of what is the probability of a sentence based on the corpus that you have used, and then model the language. And then later we will see how we can handle some of the words that are not in the vocabulary of the given corpus. Okay. So, for us to do that, we know that we require a database of this type, okay, that or a model that we have built using the corpus, and then given an input sentence, we want to predict what could be the next word. Or if you are given a sentence like this. Okay. So, is it possible to have certain type of sentences? I know I have missed R here, but I am just giving as an example how is it possible to have this sentence and what is the probability of having this. So, So, these are the two different things that we would be doing based on the language model. Okay. So, I am going to be skipping some of the slides that we had seen earlier. What we are going to be doing in this particular session is trying to create a model based on the corpus and then use the model to predict our next word using bigram, trigram, fourgram, or given a sentence, how do we really find out the probability of that particular sentence. Okay. So, in this case, there are a few things that we have to keep in mind. One is we are going to be finding the next word wk plus 1 using the context word that has that have happened before. So, in this case there are few options for us. One is we can just use the unigram, okay. Take a whole corpus, tokenize them, and then find the probability of each of the word using the method that we had described earlier. And then we can use bigrams. You know how to create a bigram corpus, and then we can use trigram. You know how to get trigrams from the corpus, and again fourgrams. So, you can go on and on. Okay. As we increase the number of grams, the accuracy of the sentence that we are forming would be better. So, we will see how that happens. Okay. So, now let us look at the language model using the unigrams. So, as you know well that we are capturing the bag of words and then finding the probability of each and every word in that bag, right. So, that means the ordering of the word is lost. So, if you want to really generate a sentence using the unigram, so how do we do that? So, where do we start? So, one possible way of looking at that is look at all the higher probability words and then start stringing them together. So, will it really work? It is not the right way to really create a sentence or find the next word and so on, because the sequence of the words in this sentence are lost, right. So, there is no order that is available, it is just a bag of words, the totally unordered set of words. So, when you look at the probability of the words and if you are going to be stringing the words based on the higher probability, if the word the would happen several times, maybe this could be having the highest probability. So, if you look at the highest probability, the legal sentences that could be formed using the unigram would be the as a sentence, right. But that is not the right way to form a sentence. So, it is not really possible to construct a sentence using unigram, but what do we do with the unigram model? So, unigram can be used to really identify the language of the document. For example, if a document contains multiple languages and you can look at each of these words and then find out whether it belongs to the language English, French, Tamil, Hindi or whatever other languages. Okay. So, each and every word can be used to identify the language. So, most of the time we use it for that purpose. So, unigram is not used for identifying the or predicting the next word or finding the probability of a input sentence. Okay, let us move on to the next. Okay, as I mentioned earlier, we are going to be generating the sentences or going to be predicting the next word. So, let us just put this in a simple mathematical model. This should be a smaller one. Okay. Probability of a sentence, the word, it is a string of words. So, I am just using the capitals here, okay, is nothing but the product of the probability of all the words in that particular sentence, right, okay. And then so this one is the distribution of over n. So, it is going to be common. So, we are going to be removing this from the formula. So, the formula would be of the form be like this, okay. And then we also want to make sure that the distribution is maintained in this fashion. Okay. So, this is a generative model. So, by using this particular formula, we are going to be either predicting the next word or finding the probability of the given sentence or the input sentence. Okay. And then we also need to understand what is the maximum likelihood estimate among all the words that are going to be coming after 2 or 3 words, which one has the highest probability. So, that is what we are going to be picking up, and that is what we call as the maximum likelihood estimate. So, this is one of the estimate that we use quite often in the language model. Okay. As I mentioned earlier, the training data or the corpus that we have used to pick up the unigram, bigram and trigrams to generate the language model may not have all the words in the vocabulary. So, I might be trying to form a new sentence with a new word that is not available in the vocabulary. So, if you use the formula, the probability of that word is going to be 0. That means, the entire sentence is going to be the probability of the entire sentence is going to be 0. So, that is not the right way. So, we need to probably smoothen this up, so that we are not losing the other elements because of the unknown word that is present in this sentence. So, we just apply some smoothing parameter, so that the probability of the sentence is not 0 if some words are not present in the given sentence, right. So, this smoothing parameter will be utilized without really disturbing the probability distribution. Let us now look at the bigram language models. Can we really construct a bigram language model, and then if we can construct, so how will it look like? Okay. So, what I am going to be doing is I am going to give the theory part of that, and then I am going to take you to the real program, and then see what and then show you what the model is, and then what model parameters are, and how are we capturing those model parameters, and then what those model parameters contain, how the probabilities for 2 words that are distributed, and so on and so forth, right. So, now let us look at the bigram language model. So, we are going to be defining the bigram language model using this formula. Okay. So, in this case, given the word, so I am going to be finding the next one wi. Okay. So, that means, we could given a pair of words, if one word is given, what could be the possible next word, what could be the probability of the next word that could occur after the wi minus 1 word. Okay. So, in this case, we are going to be estimating the parameters for all the bigrams. Okay. So, I will give an example, so that you will understand this clearly. Again, the estimation does not depend on the location of the word. So, it could be distributed all over the corpus. The occurrences of certain pairs of word could be distributed across the corpus. So, it does not really matter where it occurs, whether in the first sentence or in the last sentence or in the middle or anywhere. Okay. And then to compute this probability, we are going to be finding out how many times these 2 pairs occurred together, and then how many times wi has occurred alone. Okay. So, that is what we require to really compute the probability of the given bigram word. So, I am taking here an example where I have 4 documents. Okay. So, consider each sentence as a document. So, the first one is Peter Piper picked a peck of pickled peppers, okay, and a peck of pickled peppers Peter Piper picked. If Peter Piper picked a peck of pickled peppers, where's the peck of pickled peppers Peter Piper picked? Okay, this is a tongue twister. I thought it would be interesting to take this to construct the bigram that we are construct the bigrams which we will use to construct the language model, and then see whether a given sentence is legal in this case or not, and so on. Okay. So, in this case, what we do is we first create bigrams, and then for each bigram we compute the frequency. So, for every sentence there is a starting symbol and there is a ending symbol. Okay. So, starting symbol is also considered as a word in this case, that is why we see starting symbol and Peter as 1. So, if you look at this, Peter and starting symbol occurs once, starting symbol and A occur once, starting symbol and if occurs 1, and so on. So, this gives an idea of, okay, I want to start a sentence with randomly using whatever is available in my model. So, in this case it will find out how many times, let us say, Peter occurred as the start of the sentence, and if Peter occurred several times, the probability of picking Peter as the first word in that sentence is pretty high. Okay. So, in that way this starting symbol will really help us. Okay. So, either it is two ways you can put it. The end symbol here I marked as capital E, or it could also be used as slashes as we use in the XML formats. Okay. So, what I have done is I have computed the frequencies of all those bigrams. Peter Piper, you know how this is computed, right? So, we start with this and then like this and so on. So, every time when we pick a pair of words, we find out whether it has occurred earlier or not. If occurred, we increase the count. So, that is how we have Peter Piper occurring 4 times. You can look at this, right. So, this is the second time, third time, and then here we have the 4th time. Okay. So, in this fashion all these frequencies are computed here. So, when you want to form a sentence using this corpus, assuming that this is what we have, and then we want to find out by giving an input sentence which are going to be forming, and then find out what is the probability of that sentence given the particular corpus. Okay. So, finding the probability of this sentence is nothing but the joint probability, right. So, you take the probability of each of those occurring words and then multiply that, and finally, you will end up with the probability of that given sentence. So, if you want to find the probability of Peter Piper picked using the bigram, and this is your input sentence. Okay. The Peter Piper is going to be your input sentence. Peter Piper picked is going to be the input sentence. Compute the probability of this sentence. So, we are going to be looking at the start of this sentence and Peter, whether it has occurred. Yes, it has occurred once, and then Peter Piper has occurred 4 times and Piper picked occur 4 times. Okay. So, that means all these 3 words have been formed in this particular corpus, and they have certain frequencies associated with that. So, there will be a probability that we can compute for the whole sentence without any problem. So, the probability of this particular sentence would be high because we have this sentence, this space occurring here. Okay. So, let us look at the second one, Peter Piper picked peppers. Okay. So, we have starting symbol and Peter occurring once, right, and then Peter Piper we know it is occurring. Piper picked, yes, we have it, and then picked peppers. So, do we have picked peppers in this? We do not have this, right. So, what is going to be the probability of this, right. So, this particular one occurs so many times. So, we are going to be looking at picked peppers, the count of picked peppers, which is 0. That means, in the probability when we look at it, so we are going to be having 0 by the number of times picked occurred in the entire corpus. That means, the entire probability of this sentence is going to be 0, I think, which is not correct, isn't it. So, some of the sentence, some of the words have occurred, but only because of this word which is not coming as a pair here, we are going to have a problem. So, what we do here is, so we are going to be using some kind of a smoothing parameter, so that this particular 0 is going to have some value other than 0, is greater than 0. So, the probability of this sentence will not be as high as what we see here, but we will have some value related to that. So, in a long paragraphs and sentences, and if you want to compute the probability of whether the paragraph is legal within the context of a given corpus, so we can't have this approach, because the entire paragraph then becomes 0 in that case, correct. This when we want to compute the probability of a sentence, we would use a formula of this type, so that none of the probability of the bigrams would be equal to 0. Okay. All right. So, now we have to look at this in action. So far we have only been seeing it with respect to the theoretical formulation and so on.